Hello and welcome to a video going over linear system word problems. We're going to be talking about how to apply our ability to solve linear systems, such as by graphing, substitution method, elimination method, and really look at applying it to some different problem solving and being able to set up the right equations and all that good stuff. Okay, so Taryn is responsible for purchasing hot dogs and buns for the concession stand at the school sporting events. One week, he goes in and purchases 20 packs of hot dogs and 35 packs of buns and spends $148.45. The next week, he goes in and purchases 28 packs of hot dogs and 50 packs of buns and spends $209.62. How much does one pack of hot dogs and one pack of buns cost? That's my question. All right, so let's kind of underline some key things here. I know he's got two different trips. So one week he goes in, we got 20 packs of hot dogs, 35 packs of buns, and we spend $148.45. But then there's another trip, another week, and we purchases 28 packs of hot dogs, 50 packs of buns, and $209.62 is the total he spends. So if you remember way back, we've been talking a lot about linear systems and why we need linear systems. Sometimes there's just things where we need to model two different situations side by side. We're trying to compare them. In this case, we have 1 week shopping trip and then another week shopping trip, and they're both kind of related to the same thing: hot dogs, buns, the total cost, etc. And we're going to use this criteria to actually be able to figure out, well, what does one pack of hot dogs cost? All right, so we have two different trips, so we're going to have two different equations. Let's see if we can put down a linear system. First thing we need to do is define our variable. What are we trying to find? How much a pack of hot dogs and how much a pack of buns cost. So I'm going to let x equal the cost of hot dogs, one pack. Cost of hot dog pack. Let me write that out like that. Good to be really specific. And let's let y equal the cost of a pack of buns, of a buns pack. All right. So now let's put it together. I'm going to write a linear system here. I'm going to use one equation for each situation. So the first week we purchased 20 packs of hot dogs, and I know that each hot dog cost X number of dollars. So the total amount I spent on hot dogs would be 20 times whatever the cost is. We're trying to figure that out. So 20x. I added to that 35 packs of buns, so there's more that I'm paying out. I'm paying 35 buns, and they all had a price of Y dollars. That's Y is the cost of a buns. And the total, when I bought my hot dogs and buns, they both added up to equal a total of $148.45. All right, using that same reasoning of the second trip, we bought more. We bought 28 hot dogs at X dollars per hot dog, and then 50 buns at Y dollars per buns, and we spent a total of $209.62. And there we go. We've got our linear system. We've translated this word problem into the right linear system. Everything should have meaning, should make sense. Defining your variables is a really helpful step in that. Now we can actually go about solving this thing out. All right, so how do we want to do that? Well, I would go through and I'd probably use the elimination method. It's already set up with my x's lined up, my y's lined up all nicely. And to do that, well, let's multiply. I'm going to eliminate the y values here. So 50 and 35 to get a common numbers, to get opposites. Well, let's just go big. Let's multiply the bottom by negative 35 and the top by 50. I know that it's going to give me opposites. I just got some heavy-duty multiplication to do. All right, let's distribute. So 50 times 20 is going to give me 100x. I'm going to rewrite my whole system. 50 times 35 is going to be, whoops, 50. Whoops, I made a mistake there. Let's go back. It's not 100x, it's 1000x. And then 50 times 35 is going to be 1750. y, and then 50 times the 148. 50 times 148.45 is $7,422.50. Okay, now let's go along the bottom. Multiply everything by negative 35. Negative 35 times 28 is going to be 980. X plus negative 1750y equals, and 35 times 209.62 is negative 7336.70. All right, this may look a little ugly, but again, all we're doing is just multiplying big numbers together, and that's not too bad. All right, let's add them together and see what we got. So I'm going to use my elimination method. I've got opposites here. The y's are going to turn into 0. Now I just got to figure out what's going on with my x's and solve for x. So 1,000 plus negative 980, that's going to leave 20x. That's nice. That's not too bad. Equals, and let's do 7422.5 plus negative 7336.7. And we get 85.8. All right, so 20 times x equals 85.8. Let's divide both sides. Let me get the right color here. Let's divide both sides by 20. And what do we get? X equals 429. All right, well, what did we just find? We just found that X is the cost of a hot dog pack. We just found that X is $4.29. So apparently, a pack of hot dogs, the ones Taryn is buying, is $4.29. All right, now we just got to figure out the cost of the bun. So I'm just going to use back substitution. I know what X is. I'm going to put it in. I'm just going to use this first equation. I'm going to solve for X. So 20 times $4.29. That's the X value we just found. Plus he got his 35 hot dog buns. Let's solve now for Y equals 148.45. All right, so $20, 20 times 429 means that he spent $85.80 on hot dogs. We still need to solve for Y. Let's subtract 85.8 from both sides. That's going to go to 0, and we're left with 35 times y is going to equal 148.45 minus 85.8 equals a 62.65. And on my last step, so we're going to divide both sides by 35 to solve for what y is. So I get y equals, if I divide those, we get $1.79 exactly. Okay, so not too bad, some big numbers, but we ended up with some very exact values. Exactly got an x value of 4.29, exactly a y value of 1.79. And now we can actually answer this question. So how much does a pack of hot dogs and a pack of buns cost? Hot dogs cost $4.29. Buns cost $1.79. And so in writing that out, I kind of want to stress that when we're problem solving, we're trying to solve a problem. So algebra is great, but I wasn't asked to find what x equals. Algebra is a tool to be able to answer, well, how much does a pack of hot dogs cost? And we actually did the algebra. We got x is 429, but then we have to interpret that and answer the problem that we're trying to solve. So this would be a right answer right here, complete. We found what we were supposed to, we answered what we were supposed to. Just putting x and y and the numbers that we solved isn't a complete answer. It's getting there, it's most of the work, it's the method we're using to solve the problem, but it's not the actual answer. Okay, so hopefully this is a good example of using linear systems of equations to solve a type of problem where we have two things going on.